Hello friends, in this lecture I will discuss conjugate beam. Conjugate beam is a method to find slope and deflection under a beam. This method is given by Muller-Breslau in 1865. Let us first understand the method. Let us say I have one beam and I want to find the deflected shape equation. So what I want to find the deflected shape equation, and I also want to find the deflection under this load. So in this method we will develop one conjugate beam. Conjugate beam is a imaginary beam with certain modification in our original beam. So what I can say, we have a real beam, conjugate beam. This is my conjugate beam. That I will develop this conjugate beam in such a way that shear force and bending moment under any point will give me theta and delta of original beam. So what it means? It means that a conjugate beam is an imaginary beam developed in such a way by placing some load and end condition that the shear force of this imaginary beam, which is my conjugate beam, will give me the theta of the original beam, and deflection is equal to the bending moment of conjugate beam of original beam. So let us understand it again. So let us say this is my real beam, and some way if I develop, this is real beam and this is conjugate beam, which is imaginary. Please remember that conjugate beam is a imaginary beam. If I want to find theta and delta at this point for the real beam, then I will find shear force and bending moment of conjugate beam. So the value of shear force of conjugate beam will give me theta, and the value of bending moment will give me delta. So this is the concept of conjugate beam. So how to develop conjugate beam? So the rule number 1 is place the M over EI diagram of original beam as loading for conjugate beam. It means if I have this as my real beam, then for my conjugate beam what I will do, I will draw the bending moment diagram. So what will be my bending moment diagram? It is triangular loading, and I will put it, if it is sagging, then I will put it downward. I will put it downward. So if this is W, then this is my real beam and this is my conjugate beam. Part 1. So first is the loading. So what we will do? We will put the M over EI diagram as the loading in the conjugate beam. Now the second part is the rule 2 is end condition. which means support. So what are the supports which we require in this conjugate beam? So let us discuss how to find the support at this end and at this end for the conjugate beam. So if you see, this is my hinge support of the original beam or the real beam. Then what I know? I know that in the original beam at hinge point, at this point, there will be no delta and there will be theta only, because when this original beam will deflect for any loading, I will be having this type of deflected shape. What it means, since delta is 0 for my conjugate beam, at this point bending moment should be 0. And since there exists theta, so in the conjugate beam, I should have the value of shear force. So how it is possible? It is possible by placing the hinge support only. Because at hinge support, bending moment is 0 and shear force is always there when the hinge is at end. So this is a end hinge. For end hinge, I will be having bending moment 0 at the end, and I will be having shear force which shows that I have theta. So end hinge remains end hinge. This is the first thing, that end hinge, also known as pin, remains end hinge in the conjugate beam. Now let us discuss the roller. So what I have the condition for roller in original beam? This is my roller, and what is the condition? That delta is 0 at original beam at the point of roller and theta is there. So if I make a conjugate beam, then what I want? That bending moment should be 0 and there should be some value of shear force. How I will get a shear force here? By a reaction. So what I need? I need a roller only, again, or a pin joint, whatever it is same. So it means that roller becomes roller in the conjugate beam. So this is the point number 2, that roller is roller in the conjugate beam. Now let us see the fixed support. So what I have the condition of original beam as a fixed support? I do not have any delta here and no theta. So in the conjugate beam, what I want? I want for this beam to convert to the conjugate beam, I do not want any bending moment and any shear force in the conjugate beam. So what it means? That a fixed support is converted to a free support, because at free support I will not be having any bending moment and any shear force. So in the real beam, I have a fixed support which is converted to a free support. So what is the condition? That the fixed support is converted to a free support. Now let us discuss this free support. At free support, I will be having deformation, and this beam will deflect like this. So for real beam, I will be having delta and I will be having theta. So what I require in the conjugate beam? I require bending moment also and shear force also. So what I will do? I will convert free end to a fixed end. So if you see, at fixed end I will be having some movement and I will be having some reaction. The value of this movement will be deflection and the value of shear force will be slope. So what I learned? That the free end is converted to a fixed end. So I repeat again what we have done right now. A pin or a hinge will remain a pin or a hinge in the conjugate beam. A roller will be roller in the conjugate beam, but that should be end. At the end they should be placed. The fixed support will become free support and free support will become fixed support. Now let us take another condition, which is intermediate hinge or roller. At intermediate hinge or roller, I will be having delta 0 and theta will be there. So there will be slope because its deflected shape will be something like this. So I will be having delta 0 and theta will be there. Okay, because the slope is there for the hinge. So how I will replace in the conjugate beam? I will put a internal hinge. Now what will internal hinge do? The bending moment is 0 at internal hinge. So what bending moment will reflect? Bending moment will reflect delta. There will be no delta in the real beam. So for conjugate beam, there will be no bending moment. And second, theta is there. So in the hinge we have shear force because hinge transfer shear force. So what we learned? That the intermediate hinge is converted to internal hinge in the conjugate beam. Now last point. If I have a internal hinge in the real beam, then what I will do? It will be converted to a intermediate hinge or roller. Why? Because at internal hinge I will be having delta also and theta also. So what I want in the conjugate beam? Bending moment also and shear force also. What I need? I need a internal hinge or roller in place of internal hinge. Now let us see few of the example. I just repeat what I have done. This is my real beam and conjugate beam. So and hinge or and roller will be and hinge or and roller in the conjugate beam also. Same. Fixed end will convert to free. Free will convert to fixed. Intermediate hinge will convert to internal hinge and internal hinge will convert to intermediate hinge. Now let us see this problem. The question that in objective you will get is the conversion. Convert this original beam to a conjugate beam. So what we have to do? We have to change the end conditions. So what is the end condition? This is fixed support. So fixed support is converted to free. This is intermediate hinge. So this is converted to internal hinge. This is internal hinge. So it is converted to intermediate hinge. This is free support. So it is converted to fixed support. So this is my original beam and this is my conjugate beam. Now let us see this problem. But friends, before taking up this problem, I want to tell you that for objective you don't require such a lengthy process. So in objective you will only find the questions related to what I taught you till now. Now I am just explaining you so that you feel comfortable, but since this is a very lengthy process, conjugate beam, so there are very less chances of these type of question to come in the objective part. You just have to understand the concept of conjugate beam. I will tell you why this method is very lengthy but very powerful for structure analysis, but it is very lengthy for objective problem. I will tell you how. Let us say that I have been given a beam and I need to find the deflected shape. So what I will do, first of all, for this original beam, I will draw the bending moment diagram. So this is my bending moment diagram. Now what I will do, next part, for bending moment diagram, I will put it as a loading diagram for the conjugate beam. If you see, this is my M over EI diagram for the conjugate beam. Now what else I will do? So this is a end hinge. So here also end hinge. Now this is a internal hinge. So there is a intermediate hinge. This is a fixed support. So this is a free support. Now I will again analyze this beam. So what it means? It means that you should be very good in bending moment and shear force diagram. And minimum bending moment which you will get is of order 4 or 3. Why? Because the loading, minimum loading on the conjugate beam will be triangular. Because if originally I have a point load, then for conjugate beam I will be having triangular loading. So you should be very comfortable with the triangular loading, and it becomes lengthy. Now what I will do, for this conjugate beam, I will draw the shear force diagram again and bending moment diagram. This bending moment diagram will give me the deflection of the original beam. So how lengthy it is? You have to twice solve a beam. So in objective, Castigliano's theorem, area moment method important, then solving the question for conjugate beam. What mostly they ask the concept and this conversion of original beam to conjugate beam. So you have to concentrate yourself for the conversion only, how to convert a real beam to a conjugate beam. So I repeat what we learned for conjugate beam. First thing is that it is a imaginary beam. Second thing is that the loading on the conjugate beam is M over EI diagram of real beam. And third, we learned that end hinge is converted to end hinge in conjugate beam. End roller is converted to end roller in conjugate beam. Fixed support is converted to free support in conjugate beam. Free support is converted to fixed support in conjugate beam. Intermediate hinge is converted to internal hinge in conjugate beam. Now I give you one question and expect you to send me the solution on the WhatsApp. The question is, what is the conjugate beam for this original beam? And you can send me the WhatsApp on the number given to check whether you have done it right or wrong. And second, in the next video, I will tell you the answer of this conjugate beam. Now, the Recon Civil Academy has started a video on demand series in which you tell us which video you want and we will prepare the video for you. Thank you friends for watching this video. I hope you learned a lot of things. If you like this video, give a thumbs up and please write a comment for any suggestion which you want to give me. Also, you can WhatsApp me for any query or any doubt which you are facing while watching the video. Thank you. Enjoy civil engineering.